Morning, everyone. Our second lesson for the permutation and combination unit is factorial notation. We're actually going to divide this factorial notation lesson into two lessons, a part 1 and a part 2. Part 1 will include everything and including examples 1 and 2, and part 2 will include examples 3, 4, and 5. Part 1 we're going to complete on the Thursday before Easter, and part 2 we're going to complete on the Tuesday after Easter. So let's start today with factorial notations part 1, and let's take a look at the first part of the note. It says we want to rearrange the letters in the word fathom to see how many words we can get. So let's highlight the word letters and let's highlight the word letters and let's highlight the word words. What I mean by letters is, remember we talked about, or in an earlier example, about the little block letters when you were a young child, and taking those letters and dropping them in a cloth bag and selecting them out. So that's what I want you to think about. I want you to think that we have an F, an A, a T, an H, an O, and an M. So you've got 6 wooden block letters of those particular letters, F, A, T, H, O, M. And you drop them into a bag, and we're slowly going to select them out. Now, when it says how many different words, notice that that particular item is in quotes. I don't want you to think of it as legitimate words. I want you to think about it as letter arrangements. How many letter arrangements can we make? Not real words that we can read. So when you look at that, if I said to you, okay, hand goes in the bag, hand is swishing around the bag, how many choices do you have available to you? 6, because all 6 letters are in the box. 1 comes out, sits on my desk. How many choices do you have available to you when your hand goes in for the second pull? 5, because there's 5 letters in the bag. Block comes out, sits on the desk. How many choices do you have for your third letter? 4 choices, because there's 4 letters still in the bag. Put it on my desk. How many choices? 3. How many choices? 2 letters still floating around the bag. 2. How many choices? 1 letter in the bag. So technically, this is very, very much like the fundamental counting principle. How many choices do you have at each decision-making stage? 720 possible letter arrangements if I used the letters from the word fathom. Okay, let's take a look at another example. Say that you see one of those portable signs, similar to the one that they have out in front of Country Corner Deli, that says nice in big movable letters. You plan on sneaking back at night and rearranging the letters to say something goofy. How many words, again in quotes, can you make? So let's envision it. We sneak back at night. We take the N off, we take the I off, we take the C off, and we take the E off. They're all laying on the ground now. And we're there with some friends and we're laughing and we're thinking, geez, how could we put them up? Well, you have 4 spots to fill. How many choices for the first spot? 4. Why? Because all 4 letters are still sitting on the grass and you got to pick something to put it up. How many choices do you have for the second spot? 3, because 1 letter's already been put in, 3 were on the ground. How many choices for the third spot? 2. 2 letters are up, 2 were on the ground. And how many choices are available for the very last spot? 1. So how many possible different silly letter arrangements could you make? 24. Now, let's take it a step further. What if we said that instead of 4 letters, N-I-C-E, that you had 12 different letters that you were trying to make possible letter arrangements or words out of? Well, that would change to something that looks like this. 12. So how many choices do I have for the first position? How many choices for the second position? How many choices for the third position? How many choices? How many choices? How many choices? How many choices? Choices, 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 choices. So again, this is the fundamental counting principle of how many choices do I have at each decision-making stage. But the only difference is this is getting a bit crazy in terms of the amount of work that's needed versus the first example. So if I type into my calculator 12 times 11 times 10 times 9 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I'm going to get 479,001,600. So notice what's happening here too in both of these examples. You're actually multiplying consecutive natural numbers. Consecutive, natural being numbers with no decimals, numbers. That's what's being multiplied. But what if I said to you, oh, now all of a sudden we're going to use 26 letters. Do you think it's realistic to have to write out 26 times 25, 24 times 23, all the way down to 4 times 3 times 2 times 1? No, that's crazy. We got to come up with a better way. And there is a better way. On your calculator, you probably never noticed it before, but there's a beautiful little symbol that looks like an exclamation mark. Let me see if I can find it on mine. I should have looked at that. Oh, there it is, right there. It's right in yellow, right above the x to the negative 1. So take a look at your calculator and see if you can find that particular symbol. It's actually called the factorial button. And what it does is it multiplies consecutive natural numbers. So hold on, let's take a look at using the factorial button first on our calculator and making sure that we get the appropriate answer, and then we'll jump back to the formula, okay? So our very first example was the fathom example, which was 6 times 5 times 4 times 3 times 2 times 1. Now I'm going to type in, instead of typing 6 times 5 times 4 times 3 times 1, I'm going to type in 6 factorial. So notice I typed 6, I hit the shift button, and then I typed in factorial, 720. Our second example of nice was 4 times 3 times 2 times 1. Instead of typing it in like that, I'm going to type in 4 shift factorial. Oh, same answer. And our third example was the 12-letter example. Let's try it as 12 factorial now. Awesome. Same answer. So when you're multiplying consecutive natural numbers, we can use our factorial button. So let's take a closer look at the formula now. Okay, let's take a closer look.